In this video, I am going to explain work and tool holding devices used mainly in lathe machine. First, we'll see the work holding devices. So, the work holding devices for a lathe machine are essential components used to securely hold and position the workpiece during machining operations. Proper work holding is crucial for achieving accurate and efficient results. Here are some common work holding devices used in lathe machine. See the three-jaw chuck. You can see that three-jaw chuck. So this three-jaw chuck is mainly used for holding the work pieces. Now you can see that this is the workpiece that will be held with the help of three-jaw chucks. The three-jaw chuck is also called as an independent chuck. Why you can call it as an independent chuck? All three jaws can move simultaneously. Whenever you can use this key is keeping here and rotating, all three jaws will be moving towards the workpiece or away from the workpiece. According to, you can tighten the workpiece. Mainly this chuck is suitable for holding the symmetrical object, cylindrical objects. This chuck is suitable. And you see that what are the different parts of this three-jaw chuck. This is the Allen key, which is used to tighten the jaws or loosen the jaws. Okay, and these are the Allen keys are used to fix these jaws with this body of the chuck. And these are the three pieces which are used mainly for holding the work pieces. You can see that you can observe here, these are the grips providing. With these grips the workpiece is hold firmly while doing the machining operations. Next, four-jaw chuck. You can see that four-jaw chuck, it is an independent chuck because this each four jaws will move simultaneously. It's not moving. It's moving independently. If you want to move this jaw only, you can rotate here. Only this one jaw will move. Or if you want to move this jaw, this only can move in one jaw. Because this is required for holding the irregular shape of the objects. If the object is not cylindrical shape, other than cylindrical, any shape of the object can able to hold with the help of this four-jaw chuck, and it is also used firmly to hold the workpiece and while doing the machining operations. Now you can see in detail about this four-jaw chuck. It's a concentric circle lines are providing the body of the chucks, and these are the four jaws and keyhole where the key is used to tighten the jaws or loosen the jaws. These are the jaws. There is a four jaws are provided in this chuck. So these two are mainly used for holding the workpieces while doing the machining operation on lathe machine. Next, collets. Now you can see that collets also looks like this body is looks like the lathe chuck, but it's in inner we are providing this one more setup which is used to hold the small objects, the small circular object or precision object. If you want to hold it and you can machine using this lathe machine, then you can use these collets. Collets are used for mainly hold the small and precision objects, and you can perform the objects. Now look at this device. Now you can see that here this is the device. Once you are rotating this one clockwise and anti-clockwise, then these are enlarging or decreasing towards the job. Now you can keep any object here and you can tighten this object with the help of these. This is known as collets. Like several collets are available according to requirement. Next holding device is a faceplate. Now you look at this diagram. This is the faceplate. You can fix with the spindle of the lathe machine. And with this faceplate, there is a keyways are there. In the keyways we can provide the T bolts and with the help of the T-bolts and clamps, you can fix any workpieces, any shape of the workpieces you can fix, and you can run that workpiece, and you are going to machine that component. So wherever it's not suitable in four-jaw chuck or three-jaw chuck, in those objects you can use this faceplate and you can clamp that objects. Now you can see that there is a several varieties of face plates are provided or designed according to the requirement. These different varieties of face plates you can fix. Now you can see that each face plate is mounted on the lathe spindle. There is a threads are there. There is internal threads and lathe spindle of the external threads are there. So now it's directly fixing on the lathe spindle, and once spindle starts rotating, this face plate also starts rotating. So with the help of the faceplate, we can hold any irregular shape of the objects, and you are going to do the machining operation in lathe machine. Next, mandrel. You can see that the mandrel is mainly for the longer jobs, lengthy jobs. You want to support one end is fixed to the chuck and other end is support with the help of the tailstock spindle. Then we are using these mandrels. Okay, and with the help of the mandrel, we can support other end and one end is fixed to the job. Now we can do the machining operations. Okay, so why you are required this support is so in order to once this end is fixed, if we want to apply any force here and doing the machining operations, and because of this cantilever nature, this entire setup will try to bend. So in order to arrest the bending movement of the shaft or device which you want to machining, we are providing the supports. That is, this is a one support, that is a mandrel, where whenever you are doing the axial shafts, cutting the keyways on the shafts, or doing some splines on the shafts or axles machining, you are generally using the mandrels. You can see that several the mandrels, the different sizes and shape of the mandrels are used to support the workpiece and while doing the machining operations. Next is drive plate. Now you can see that this is the drive plate, and using the drive plate is directly fixed to the lathe spindle, and the drive plate will start rotating. Okay, now we are providing the lathe dog. The lathe dog. This lathe dog is consist of one portion is supported the workpiece. Let us hear the workpiece, and other portion is like a leg that is inserted slot in the drive plate. Once drive plate starts rotating this direction, it will push the lathe dog, and the dog is starts rotating, and this dog is mounted to the workpiece and the dog, so the workpiece also starts rotating. Okay, so likewise you can do the drive plate to run the workpieces. You can see that here the drive pin, with the help of the drive plane, the drive plate will starts rotating the workpieces. Next, catch plate. Now you can see that here it looks similar to the face plate, the catch plate. Now this with the help of this catch plate is rigidly fixed to the spindle. Once spindle starts rotating, the catch plate also starts rotating, and it having the provisions to keep this lathe dog and all the setups, and we can with the help of these catch plate, we can mount the different work pieces. Now you can see that this is one of the setup we are using catch plate to mount the work pieces and run the work pieces. Now you can see in detail about this diagram of the catch plate. Now the catch plate is fixed to the lathe spindle, and this is the support provided from the lathe spindle, that is live center, let us, and this is the dead center from the tailstock, and we are providing this lathe dog, and this dog will inserted in the hole. Here see that these are the lot of holes are there. At particular hole it will insert leg of this lathe dog, and once this catch plate starts rotating, and this device also starts rotating, and the workpiece is mainly rotate due to this power transmitted from the catch plate via the leg to this device to the workpiece, and these centers are mainly used for supporting the longer workpieces. Only it will support and it can rotate firmly about that support, but that main driving force is obtained due to this the leg of the device. This is for the catch plate. Next, steady rest. Now you can see that the steady rest. Now here for lengthy jobs, you can see, suppose you want to machine very bulky objects, then one of the object is fixed on the lathe chuck. It may be 3-jaw chuck or 4-jaw chuck according to the shape of the component. If it is cylindrical, you can use the 3-jaw chuck. If it is uncylindrical, you can use the 4-jaw chuck. And one end is fixed and other end is supported with the help of this device. This device is known as a steady rest, and it's support and it allows the driving of this cylinder or object. And now you are doing the machining here. You can see that you are doing the machining. If not providing this support, and what happened because of this overall hanging of the workpiece, it try to bend. Once we are applying the forces, then it will try to bend. In order to arrest that bending, it firmly supported with the help of the device. This device is known as a steady rest. The steady rest is fixed on the lathe bed. So it's moving on the guideways of the lathe bed. At where you require position, there you can steadily fix it and do the machining operation. That is the steady rest. You can illustrate this steady rest. You can see that. So these steady rest can be moved in this. These are the guideways, the lathe bed guideways. There is two set of guideways are there. In these two set of guideways, this device will be moved along the tailstock to the headstock. Wherever you required, it will move, and the workpiece is firmly fixed here. There is a jaws will be provided, hinges are provided, and you can tighten the screws, and the workpiece or cylinder or bulky objects will be tightened here and do the machining operation. There is a two set of these steady rest. This is a closed steady rest and open steady rest. Here you can see that only that like a C clamp, you are providing, and this side you are providing the cutting tool to make the machining operations. It's easy, and once you are applying the force in this direction, now you can see that it will support here. It will support here. Okay, these two devices will support without any bending of the shaft. That is a possibility of using the steady rest. You can see the several examples of steady rest. So this is the one example. This is the another example. So these are wherever required on the lathe bed guideways, we can fix it and support the workpiece and do the while doing the machining operation. Next, follow rest. So the steady rest is a fixed one, but follower rest is also similar to the steady rest, but the follower rest is moving along the job wherever required. It's freely move according to the requirements. It's freely move, but steady rest is steadily fixed while doing the machining operation. But here also this follower rest can move wherever required while doing the machining operation. Now you can see that this is the follower rest. So here also looks similar to the steady rest, but it's a follower rest. You can see that only that one guideway. It's simply just moving on this one guideway, and it wherever required you can move it and you can support the workpieces. This is known as a follow rest. The different shapes are you can able to see that. Lathe centers. Already we know the lathe centers. We have the two centers, that is live center and dead center. For longer length of the jobs, we are using the supporting of lathes. We are providing here so many shape of lathes and centers. Now you can see that once we are inserted in the tailstock spindle, and this end is supporting the workpiece. You can see that this point is supporting the workpieces. This point is supporting the as for the requirement, there is a several shapes. Okay, whether it is a conical point, or you can see that truncated conical shape of this once that portion of the shaft end is supported here and starts rotating like this. There is a several varieties of shapes are we are using as a lathe centers. Okay, now you can see that the example of the chuck, the lathe chuck is fixed at the job, and other end is supported the point, and the job is starts rotating. The tool post. Now coming to the tool holding devices. The tool post. So with the help of this simple tool post, you can able to fix the tool. Now you can see that here there is a one way you can fix, and here is another way you can fix. Like that, 4 ways you can use of these knots. You can tighten, and you can use the fix the tool. Okay, now you can see that the indexing type of tool post, that four-way tool post, we can see that four-way tool post, how the tools are fixed. This is the one tool, and this is the second tool, and this is the third tool, and here it is one more tool is there. The four tools we can fix it as and when required, the different operations without any changing the tool. You can directly you can use these four tools to perform the four different operations on the lathe machine. So that is the main advantage of the indexing type of tool post. You can see that here once this tool post is fixed, now this is the device. You can see this device is having these graduations and rotations. You can set what are the required graduations moving forward direction, and also this entire device will swivel along this in order to make the taper turning operations. We can set different angles and we can perform the taper turning operations. This regarding the tool post. Tool holder. So the tool holders, different tool holders are required to hold the tools. Now you can see that this is the tool we want to mount on this tool holder. This is the tool holder. This tool holder fixing on the cross slide. Okay, and compound slide, cross slide, wherever that possibility is there, you can fix it and it will move along in this direction. This entire it will move, but here you can fix the tool and the tool can use it to machine the component. The different varieties of the tool holders are there. Here it is one variety of the tool holder. Here you can fix the tool and tighten with help of these two Allen keys, and you can use the machining. And you can see that another type, like the several types of tool holders are available in the market. You can use any suitable tool holder and you can fix the tool. Now you can see that another, like the different varieties of tool holders are available. We can use those tool holders and hold the tool firmly and do the machining operations on lathe machine. Boring bar holder. Now you can see that boring tool. So you know the boring tool you use it to enlarge the already drilled hole. Now you can use here. This is the place where you can insert the boring tool, and the boring tool will move inside the hole and enlarge the hole. Okay, now you can see that the several boring parts are that inserted. Now you can see that it's the same device. These are the boring tools. These boring tools are firmly fixed on this hole and use this for making the boring operations. Now you can see that clearly. This is a one more the device which is used for boring operations. Now you can see that this is the boring tool. The boring tool is inserted here and tighten, and this can also guide along these jaws, cross slide guideways, and we can move the tool to enlarge the hole. Next, parting tool holder. So whenever the parting tool holder is used to parting off the workpiece, that means the workpiece you want to separate from the main workpiece, then you can use this type of devices. Okay, you can see that this type of device, this is the tool. This tool will cut and the entire the portion will be separated from the workpiece. That is a parting tool. You can see that there is a several parting tools are provided. Here this is one, the small, or if you want the small groove also, like for rings. Whenever we are going to provide some oil rings, then we can require some groove. That operation also we can perform with the help of this parting tool holder. This is the another way, and this is, you can see that this will go directly inside up to this center, so that this entire piece is separated from this workpiece. That also we are using this. Or if you want to make small groove, we can operate like this. Also we can perform with the help of this parting tool holders. You can see that there is a several parting tool holders. These are the parting tool holders, and these are the Allen key to fix these tools with the tool holder. And knurling tool holder. You can see that this knurling tool holder, and this is the knurling tool holder. You can see that the null, we are providing the impression on the workpiece, and these two nulls are fixed on this holder. This is the knurling tool holder to perform the specified the design on the workpiece for the gripping purpose. Okay, now you can see that there is a several varieties of work holding, the tool holding devices are available for knurling. You can see that here there is one more simple, here another spring type of the knurling tool holder. Okay, So next, grooving tool holder. To make the grooving operations, then you can use the grooving tool. This grooving tool will fix on the grooving tool holder, and like the several shapes, or you can see this is the another shape of the grooving tool, and this is the another shape of the grooving tool. The lot of the tools are used. It looks like a potting tool also. But you are providing the small groove, you can use the potting tool, and if you want to separate the entire workpiece, you can use the potting tool. Sometimes it's similar to the potting tool also. That grooving tool holder, mainly the main aim is to make a groove on the circumference of the workpiece at a certain depth. So I hope everyone can understand what are the different work holding devices used in lathe machine.